Hello, Ken. Thank you so much for making the time. It's a real pleasure to be speaking with you and to talk about haptics, something both of us are passionate about. Your pioneering work, especially with the Phantom device, has been foundational for the entire haptics community. So to start off, I'd love to get your perspective on what you see as the top scientific or engineering breakthroughs in haptics over the past 2 decades.
Yeah, well, thank you for inviting me, Hong. It's a pleasure, and hello, everybody in the audience. I'm sorry I can't be there with you. Um, so, three scientific engineering breakthroughs. Well, first, I should clarify, my perspective on haptics is from the force feedback point of view, not so much vibration or some of the other effects that people are looking at intensely. I still think about telemanipulation and phantom-style haptics. Breakthroughs, commercially available devices, they're starting to be a number of haptic devices that people can use for experimentation or application. Haption, 3D systems, Haply. Haply has some relatively low-cost haptic devices. We started with the Phantom at $18,000, and now we're down to $1,500 for a decent three-dot haptics device. So devices are starting to become more available. They're still not cheap enough, and they still don't have the performance that I think we really need. Haptics toolkits. Chai has been around for quite a while, but lots of people use it, Open Haptics, and I'm sure there are lots of other toolkits to make it accessible so everybody doesn't have to create the rendering capabilities. And then just rendering techniques for soft and hard materials has sort of expanded the range of effects that can be displayed. Partly that's algorithmic, partly it's computational availability. But all these together are leading to much richer haptic, physically interactive haptic environments.
Awesome. Thank you so much. Yeah. So in the commercial world, what products do you feel like haptics had the most significant impact on?
Well, again, speaking of force feedback haptics, surgical simulation, I've started a small company that does patient-specific surgical simulation for skull-based surgery where you need to drill through the bone. And we've found that having haptic feedback while the surgeon is rehearsing and planning those difficult procedures really is valuable. It helps them develop a cognitive map of the procedure that they're going to perform. Clearly, the psychophysics world has benefited from haptics, giving them a controlled environment to do all sorts of experiments. And my colleagues on the panel certainly understand that way better than I do. Surgical robotics, teleoperation is haptics plus robotics, and surgical robotics, recently the Da Vinci robot is beginning to have some force feedback, which means the haptic interface comes into play for that. But one of the things that got me really excited in the world of robotics and haptics was Toyota's announcement back in this, I think it was the fall of 23, using teaching by demonstration and diffusion policy to teach robots how to perform difficult tasks. And they did that by teleoperation. So they needed a haptic interface to control the robot and feel what the robot was doing. And so, more and more teleoperation is becoming a part of robotics. A great example is in medical robotics. The Da Vinci and now Johnson & Johnson and Medtronic and many other companies are using teleoperation to do surgery. And what's exciting about that is that they're able to collect the data of the process. And so teaching by demonstration through teleoperation is becoming more and more realistic to do in the surgical domain, because they're just gobbling up the data, accumulating data of surgeons interacting with tissue. So I find that exciting.
Yes, I guess we're already into the realm of sort of what gets you excited about the future of haptics. Anything additional that you're excited about, and also what do you think of these new developments in AI and all that? How would that impact the future haptics?
Um, well, from a design point of view, I sort of see that robotics and haptics are merging. The force feedback haptics that we started with the Phantom, and were preceded by other force feedback devices, but the Phantom made it accessible. Um, the purpose of that kind of haptic device is to communicate to a human information that's either virtual or remote if they're doing teleoperation. Well, the same applies to the design of a robot. In today's cobots, although people are excited about them, they really don't have the bandwidth or the backdrivability or the low inertia that we aspire to in haptic interfaces. And so I can see robots evolving to become more like the force feedback haptic interfaces that we know today. So I'm excited about that. Another application that I'm looking forward to is haptics in CAD systems. And I can see two uses there. One, improving the user interface so that you can physically snap to a vertex or an edge or a surface. But even more interesting is being able to modify a design. If you have a constraint on the volume of an object and you want to pull a corner of it a certain way, making that a physical process where you do work in concert with changing the shape of an object. And then kind of the third level would be interacting with mechanisms. So if I'm creating a door closing mechanism, and which is a combination of spring and damper, and I'd like to exercise that mechanism and physically interact with it. And a lot of engineers who do design have good imaginations, but not everybody does. So being able to physically interact with designs as they evolve, I think, is an opportunity that's yet to be realized.
What challenges do you anticipate the field to face moving forward?
So to clarify my thoughts on that, let me show you a picture. So let me pause for a moment to share my screen. So this slide, which Lynette Jones created probably in the 90s, still captures some things about haptics that I think are important to realize. And these are logarithmic scales in displacement across the horizontal axis and force in the vertical axis. And what she illustrates here is the degree of capability needed to perform certain kinds of tasks. So for example, electric assembly and microsurgery, maybe 10-to-1 range of motion and 10-to-1 range of forces, where a different task, maybe driving a car, may require larger motions and larger forces. And so on this two-dimensional plot, you can describe task demands, and then overlaid on it, she shows roughly what the hand can do and what the arm can do. And in the two working together span all of the tasks that humans are able to do. And yet the dynamic range, by that I mean the range of maximum force to minimum friction backdrive force, still is not very good with force feedback devices. Maybe 50-to-1, 100-to-1 is a pretty good haptic interface, and yet humans can perceive or exert 4 or even 5 decades of range and force. And so we've got a long ways to go to psychophysically span the range of what people can perceive, as well as cause actions in. In video, we figured out what the frame rates ought to be and what the pixel density ought to be, but I think we have a long ways to go in haptics yet to match human capability and really utilize that information channel.
Yeah, that's a great illustration.
Another challenge that I think is interesting is the hand interface to a haptic device. Right now, we have pretty simple pinch grip capability, such as on the DaVinci, or even simpler with the 3D Systems touch interface. It's just a button that you push, The same with the Hapley device. And yet we have multiple fingers, and there have been thousands of attempts to build hand interfaces that are large and awkward. And the question is, can we build something that interfaces maybe just 3 fingers, but gives us force feedback to all 3 of them? And then there's the interesting mapping question of how do I map that to a robot that may not be configured with the same kinematics as me, so it's not kinematically similar, and yet we still want to control multiple degrees of freedom. So I think there are lots of opportunities for designing better human hand interfaces into the haptic devices.
Mm. Yeah, so maybe related, I was going to ask you about, what is most needed for significant developments in the field for the next decade. So in that regard, can you make some additional comments about, the needs for sensors, actuators, form factors you kind of mentioned, or applications?
Yeah, well, I think that the bottom line is actuators and transmissions. In the early days of the Phantom, we had ironless armature motors from Maxon that actually had pretty good backdrive, but low backdrive friction and low inertia. Motors, continue to evolve. Low ripple, high range of high dynamic range, high bandwidth are all desirable properties that will help us span the range of human capability. So definitely, I'm excited about actuators getting better. There's this notion in the among people who want to automate factories or have robots out working in the world of a call center where if the robot gets stuck, it needs to call to the call center and have humans direct them through their task. And that's an opportunity for sort of a blend of haptic interfaces with teleoperation where you're connecting to different robots as the robot needs help with performing its task. And I think that there's some real opportunities there.
That's great. In closing, what advice would you offer to newcomers coming into the haptics field today?
Roll up your sleeves and get involved with the physical interactions. A lot of my inspirations in haptics came from physical interaction, working with tools or working with musical instruments and just observing what I do with my hands. As in design, the sooner you can have a physical embodiment of your haptic interaction, the more you'll be able to rely on your deeper intuition to guide you in your research or your development. So even lower cost haptic devices, and I think Karen can speak about this. I think it was the DYI2 program that she developed, which is a really good outreach to get people involved in physical interaction. The thing about haptics is it appeals to, some people are verbal, some people are auditory, some people are visual, and some people are haptically oriented or mixtures of all of those. And so it's important to accommodate to that community and give them the tools so that they can interact and discover, their own capabilities.
Do you have any suggestions for how we can grow our community?
Oh, okay. So in the robotics world, the first competition has really put energy into and learning capabilities into the world of robotics. Now when new students come to me at Stanford, many of them have built complex robotic devices and understand the ins and outs of motors and sensors and computation and everything else. It'd be nice to see something in haptics that generated as much excitement. Maybe including haptics in the first competition. They do have a teleoperation modality for part of their contest. So if we could enable them to have some degree of force feedback or vibratory feedback, or whatever we can bring to bear to communicate between them and the robot, because that's such a vibrant community. If somehow we could tap into that, I think that would be exciting.
So can you say a bit more about the first competition? I'm not sure I'm aware of it.
Yeah, the first competition actually grew out of a course that we used to teach at MIT called 270. But basically, there's a contest that is defined every year, and students form teams. Typically, it's a high school team of 10 to 20 people, and they build a device or a vehicle that will compete in a round robin basis with other schools. And a typical contest will be to collect all the golf balls or throw basketballs into a target or throw frisbees into a target. So it's mechanical, it's electronic, there's semi-autonomy, and with the increases in autonomous robot capability first is good, really letting people get a taste of that early on.
Yeah, we have to think about this. Yeah, so it's an annual event.
Yeah, they get the contest definition in January, and they only have about 6 weeks, so it's an intense experience of designing, building, prototyping, refining, and ultimately competing. And one of the things I like about the first community is people tend to help each other out. You might be borrowing the batteries from one of your opponents, so that you can compete in your round, and then when it's their turn to compete, they borrow your motors or whatever. I mean, it's a very collegial, very upbeat kind of community.
Yeah, I need to look more into that. Yeah. Thank you so much, Ken. Any closing thoughts, stuff that I have not brought up yet?
No, I think we've covered most of what I wanted to share. I really appreciate the opportunity, and I'm sorry I couldn't be there with you. Hello to everybody on the panel, and enjoy the rest of the day.